Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is example problem 74 to 76 about moment of a force about a point. The rectangular sheet of plywood is held in position by the cable. The tension in the cable is 150 newtons. Determine the moment of the force exerted by the cable on the plywood about corner A. So here's the given figure, and this distance is along Y is because this is 1 meter and 30 degrees. This is 1 sine of 30, so 0.5, and this one is 1 cosine of 30, so square root of 3 over 2. So this is the force. This is 0.5. 0.5 is 1 meter. This edge of the plywood times sine of 30, so 0.5. This vertical distance from A to D, vertical distance is 1 cosine of 30 or square root of 3 over 2. So the force is directed backward, so negative 2I. Rightward, 0.5 plus 1.5 is 2j. Then downward, negative square root of 3 over 2k. So the force is 150, quantity negative 2i plus 2j minus square root of 3 over 2k over magnitude of distance 2 square plus 2 square plus square root of 3 over 2 quantity square. So F is equal to negative 101.42i plus 101.42j minus 43.916k newtons. So having found the force, then let's have a box as our guide. A is at the box, C is at this point. So this is the box, and C is here, A is there. Then the distance between C and A, this is along Y, is 0.5. Along X is 2, and along Z, square root of 3 over 2. So square root of 3 over 2, that one. This is 0.5 and this is 2 meters. So that it's easy for you to analyze. So the force is at C and the components are the following. So that MAX, this is the positive sense of moment. MAY, that's the positive sense of moment by right thumb rule. MAZ is that positive sense of moment. So MAX is, so this is positive 43.916 times 0.5, then minus 101.42 times square root of 3 over 2. MAX is 43.916 times 0.5 minus 101.42 times square root of 3 over 2. So MAX is equal to negative 65.87 Newton meter. Then MAY, this is the positive sense, so this is positive, same sense as this 43.916 times 2, then minus 101.42, that's negative, opposite to this sense, times square root of 3 over 2. So MAY 43.916 times 2 minus 101.42 times square root of 3 over 2. So this 101.42 is not involved because it is parallel to the y-axis. So MAY is equal to 0. So it is really 0 because the force passes through. You look at the original figure. It passes through this point. This is the y-axis. So that's why moment about AY is equal to 0. So it only checks that it is really 0. Then MAZ, this is the positive sense. MAZ is equal to 101.42 times 2. Then minus 101.42. This is minus because it is opposite to this sense here. 101.42 times 0.5. So MAG is equal to 152.30 Newton meter. So therefore, in vector form, MA is equal to negative 65.87 I plus 152.13 K Newton meter. Then for the vector approach, it is RCA cross RAC cross F. MA equals RAE. It is also RAE cross F. So we'll use this. It is also RAC cross F, but this is simpler because AE is just 1.5 J. That's the only component of this position vector. So 1.5 J. The rest X0, Z0. So MA equals 0, 1.50 components of the force, then unit vectors. And copy the first two column elements. Then let's evaluate. So 1.5 times negative 43.916 is I, then minus 0. So 1.5 times negative 43.916, it is negative 65.87. Then along J, it must be 0. So 0 minus 0. So it's really 0 along J. Along K, 0, then minus negative, so plus 101.42 times 1.5. 101.42 times 1.5 is 152.13. Therefore, the moment A is negative 65.87 I plus 152.1 K Newton meter. Then that's it for your part. Cable BC has a tension of 50 pounds. Determine the moment about corner A of the force exerted by the cable on the box. So here is a given figure and show that the answer is this. You may solve this into two ways also, scalar and vector approach. Problem 75. A force of magnitude 360 newtons is directed from point A at 4, 3, negative 2 meters to B, 6, negative 1, 3 meters. Compute the moment of the force about point C, which is at 1, negative 2, 4. So remember that the force is magnitude of the force times delta x. Delta x is terminal coordinate x coordinate minus initial x coordinate. Same is true with y and z. So therefore the force is 360 in vector form times 6 minus 4, so 2i, negative 1 minus 3, negative 4j, 3 minus negative 2, positive 5k over distance square root of 2 square plus 4 square plus 5 square. So FAB is 360 times 2i minus 4j plus 5k over square root of 2 square plus 4 square plus 5 square, where 2i is 6 minus 4, so 2, negative 1 minus 3, negative 4, 3 minus negative 2, positive 5. So that's FAB. So FAB is 107.33i minus 214.66j plus 268.33k. Then let's draw a box. So the position of C and A must be established. So I'll put the force at A. That's the reason. So considering A and C, A is in front of C because this is along X. So A is in front of C because A has X coordinate of 4 and C has only X coordinate of 1. So the difference between 4 and 1 is 3. So this is 3. A is also to the right of C because C is negative 2 and A is 3. So it's rightward and C is in the left. So it's correct. Then A is negative 2, C is 4. So 4 is above -2. So that's why C is above A. So for the dimensions of this box, this is 3 along X, along Y, 5, where 5 is -2 and -2 minus 3, so 5, or 3 minus 3 minus -2, that's 5. Then along Z, 4 minus -2, so it's 6 along Z. So this is the box. Then let's put the components of the force at A. RCA therefore is 3I plus 5J, then minus 6K. 3I forward, 3, rightward 5, so 3I plus 5J, then downward 6, so minus 6K. That's the position vector RCA. So these are the components of the force, and we have X, Y, Z at C, then our guide for positive moment. So moment about Cx by the scalar approach is 268.33 times 5 positive, then minus 214.66 times 6. So MCx is 268.33 times 5 minus 214.66 times 6. So that is 53.69 Newton meter. MCy this is negative, opposite to this sense. This is also negative, opposite to that sense. So negative 268.33 times 3, then negative 107.33 times 6. Moment arm is 6. So MCy is negative 1449 Newton meter. MCz, negative, negative. So this is the positive sense. So negative, negative, negative 214.66 times 3, then negative 107.33 times 5. So MCz is negative 1181 Newton meter. Therefore, in vector form, MC is 53.69I minus 1449J minus 1181K Newton meter. That's in scalar approach. In vector approach, RCA is already there. Then components of the force, RCA cross the force. So components of CA 3, 5, negative 6, components of the force, then unit vectors. Then we copy the elements of the first two columns. So for the result, 5 times 268.33, which is this, minus 214.66 times 6. This is minus, but the product is positive, so still minus 214.66 times 6, which is that. So that's why it's 53.69I. Then along J, negative 6 times 107.33, which is this, negative, then minus 268.33 times 3, which is this, minus 268.33 times 3. So it's negative 1449. Then along K, 3 times negative 214.66, which is this, negative, then minus 107.33 times 5, which is this. So it's the same. Therefore, MC is 53.69I minus 1449J minus 1181K Newton meter. So for your part, this is your problem. A force of magnitude for 20 newtons is directed from point A to B. Compute the moment of the force about point C. And show that this is the answer. So solve this into two ways like what I did here. Determine the smallest force F that must be applied along the rope in order to cause the curved rod, which has a radius R 5 feet, to fail at the support C when the moment developed there exceeds 80 pound-foot. Other given data are A 7 feet, B 6 feet, and theta 60 degrees. So here is the given figure. So A is 7 feet, B 6 feet, and theta is, take note, this is 60 degrees. Therefore, because R is 5, this distance, horizontal distance along Y, is 5 sine of 60. 5 sine 60 is 4.33 feet. So the horizontal distance between A and B therefore is 7 minus 4.33, and that is 2.67. Not shown here, but the delta Y between A and B is 7 minus 4.33, 2.67 feet. Then this vertical distance between A and the floor, XY plane, is 5 cosine of 60 degrees. So that's 2.5. So let's draw a box. FAB therefore is 6i along X, then along Y 2.67j. 2.67 is 7 minus 4.33. Then along z-axis is 2.5 downward, so negative 2.5k over distance square root of 6 square plus 2.67 square plus 2.5 square. So FAB is equal to F 0.8538i plus 0.3800j minus 0.355k. So MC therefore is, let's just apply vector approach in order not to complicate the drawings here. So RCB cross the force. It is also RCA cross the force, but RCA is 4.33J. Then because this is 2.5 minus 2.5K, 5 feet minus 2.5 is 2.5K. You may solve this problem again using RCA cross F. That's simpler because there are only two components for CA. But RCB has three components, 6i, then plus 7j, then minus r minus 5k. MCA is 6, 7, negative 5, 0.85 components of force, then unit vectors, and copy the first two column elements 6, 7, 0.8538f, 0.38f, ij. So along I, 7 times negative 0.3558, then minus negative, so plus 0.38 times 5. Along J, use your calculator, negative 5 times 0.8538f, then minus negative, so plus 0.3558f times 6. Then along K, 6 times 0.38f minus 0.8538f times 7. So the result, MC is negative 0.5906 Fi minus 2.134 Fj minus 3.697 Fk pound-foot. Then we equate the magnitude of this moment to 80 feet. So MC is square root of 0.5906 F square plus 2.134 F square plus 3.697 F quantity square equals 80 pound-foot. So 4.309 F, this one, magnitude of M sub C, equals 80. So from there, we can solve for F. F is equal to 18.57 pounds. Then for your part, here is your problem. The man pulls on the rope with a force F. Determine the moment that this force exerts about the base of the pole at O. Solve the problem in two ways, one scalar approach and one vector approach. So that's it, and show that this is the answer. These are the other given data. So MO equals 61.2I plus 81.6J Newton meter.